Okay, so we're working on number 3. It says a compound has the following percentages by mass: barium 58.8%, sulfur 13.74%, oxygen 27.4%, 3% determine the empirical formula. So the empirical formula, remember, is the lowest, most reduced form of a chemical formula. So first we're going to convert these percent to grams. And so if we assume that whenever we see this percent composition, we can assume that the total mass is 100. So basically 58.8% becomes 58.8 grams, 13.74% becomes 13.7 grams, and 27.43 becomes 27.43 grams. Okay, so now that we have grams, we can convert to moles. Remember, an empirical formula, any formula, is a molar ratio. So I have 58, so our first one is barium, right? So 58.8 grams. We're going to convert that to moles. So barium has 137.33 grams. So if I convert that, so 58.8 divided by 137.33 gives me 0.428 moles of barium. All right, so we're going to convert all of them to moles. So if I look at oxygen is, we start with 13.74 grams. The molar mass of oxygen is 16.00 grams over 1 mole. So 13.74 divided by 16 will equal 0.859 moles of oxygen. And then the last one is, I did the wrong one, sorry. Let me try that again. So it looks like sulfur, so barium is 58.8, sulfur is 13.74, and oxygen is 27.43. So let me go back and do sulfur. So sulfur is 13.74 grams times. So sulfur, its molar mass is 32.07 grams. This is 1 mole. So 13.74 divided by 32.07 equals 0.428 moles of sulfur. And then if I did oxygen here looks like 27.43 grams. So 27.43 divided by 16 gives us 1.71 moles of oxygen. So the next step in the empirical formula is, now that we have this moles, we now have to get them into whole numbers. So we're going to divide by the smallest number of moles. The smallest number of moles is 0.428, so divide everything by 0.428. So this will give us 1, and then 1.71 divided by 0.428 equals around 4. So now we figure out the empirical formula. So for every 1 barium, there's 1 sulfur and 4 oxygens. So that's our empirical formula.